I can welcome you in. Yeah. So, all right. Good evening, everyone. Good evening once again. I'd like to welcome you all to the panel AI for Power, Accelerating the Clean Energy Transition. We'd especially like to thank the Ministry of Electronics and Information Technology, the organizers of the India AI Impact Summit, for giving us this opportunity to discuss the impact of AI on grid transformation. I'd like to start by inviting Dr. Mahesh Patankar to present the work that MPEN Systems is doing in this space. Yeah.
So right in the sequence. Okay, so good evening everyone, and thank you again, Rishi, Nalin, and other co-organizers, including BRPL, new friends from other organizations, and the audience here. What we'll do is I'll just quickly run through what we have been doing as a part of Impin Systems activities. So primarily, we have been sort of focusing on multiple things, including power sector, greening of rural value chains, electrification on mobility, and some of the things that we're going to discuss today span across transmission, distribution, generation, and also resource adequacy, demand flexibility opportunities. I'll focus a little bit more on demand flexibility in the next 2 to 3 minutes before I hand it over to Rishi. Primarily, there are several opportunities in which the power sector and the end use consumption techniques can be merged together. So one of the key things that we have been focusing on is AI in the building management systems. So conventional wisdom of building management systems is about optimizing air conditioning, but one of the key things that we have been watching is basically all the changes that we see because of the climate change and the ambience changing, the humidity levels, wind directions, and everything changing, because of which the renewable energy generation on-site as well as off-site and the requirement for the specific comfort cooling changes drastically. So one of the key applications that we have been watching out for is basically how do we really predict the weather, and how do we predict the on-site generation, off-site generation, occupancy levels, etc., and how do we really optimize for the AI application in that specific zone. So buildings is a very already start developing some application areas through the AI applications and ML applications as well. Moving beyond, we have been talking about the load management, and in this particular case, the use case that we have been exploring is electric vehicle charging infrastructure. So it can happen at a large Delhi Transport Corporation bus depot. At the same time, individual two-wheeler charging opportunities. And here it's a sort of very interesting mix, which is at the micro level, which is at a home level charging. And if you can manage that predictively, and if you can manage that predictively based on the power pricing as well, I think there is a good inference that one can draw. And then also optimize so that two things can be achieved. First and foremost is electrons are available at cheapest rate and the cleanest opportunity that we see from the electrons wherever the charging can ramp up. So the charging, the thermal cooling system, thermal energy storage systems, as well as electric vehicle charging infrastructure is basically nothing else but battery energy storage systems. So can we use the end use itself to also provide for that opportunity? And in the recent past, there is an experiment that we facilitated and evaluated on going from vehicle to load and vehicle to grid or vehicle to home. Vehicle to load is absolutely sort of important and here and now opportunity for the AI itself. The third thing that we have been talking about is demand flexibility, and this is very important from the perspective of the load shift that we see in the power markets. So typically in the past, we would have seen the load shifts which peak in the morning time, and then you also have a peak in the evening time. And because of the, again, weather changes, climate changes, etc., several discom territories have started experiencing peak demands at midnight. And that's again the cooling load that we are seeing. And how do we really optimize for that peaking of the demand at midnight? And how do we really transfer that to the afternoon peak power generation from the renewable energy sources? And here we are talking about solarization. So that's a very important aspect. And what we have been able to do is to get this variable inform renewable energy to be absorbed in end uses. So there are several examples such as a pre-cooling or thermal energy storage systems, or even water pumping, a simple water pumping for a municipal corporation. If you can predict what is going to be the consumption of water during the coming summer, coming winter. So it's not only about the diurnal consumption and the changes thereof, it's also the seasonal storage opportunities that one would sort of see in that space. So that's another very important aspect. And also would like to mention here, there is a lot of regulatory support which also is required by AI, and AI is also required for a benign regulatory framework to be developed. So just to give a reference here, if you're looking at sub-distribution level investments, new transformers, new cables to be drawn and so on, typically the regulatory space starts looking at is this investment adequate? Now, if we were to really look at the viability of the DISCOM as a business itself, you need to be very sure if you can defer the investments or you can even nullify that investment. And all of that can be done again through predictions, and then that's where we clearly see an opportunity for the AI to come into play. So I'll pause here. We're happy to sort of take any sort of questions and reflections later during this session. Handing it back to Rishi. Thanks, Rishi.
So, sorry. So, in addition to what Mahesh had presented, we also wanted to highlight a very specific model or a platform that is focused on AI for power, right? So I wanted to introduce this program called Electron Vibe, right? And I wanted to start by stating a couple of things, right? One is that India has set very key targets, right? 500 gigawatts of non-fossil fuel power capacity, 1 crore rooftop solar households by March 2027, and that EVs should be 30% of overall sales by 2030, right? So what is the real link here? It is the need for a modern, resilient grid, right? One that can handle more rooftop solar, distributed energy resources, new loads of EV charging, and more day-to-day variability, while still delivering reliable service. That's why utilities need practical tools that improve the grid and how it is planned and operated. Right? So just to give a bit of background, my name is Rishi from Climate Collective, and Climate Collective was actually started by renewable energy developers, people who've built projects on the ground, and built Climate Collective to support the next wave of climate solutions to be adopted and eventually scaled, right? Today, we're the largest early stage climate tech startup platform in the global south, having supported close to 1,500 startups, 509 of them being women-led startups, through almost 100 accelerator programs that we've run. Right? So more specifically, our understanding of the power sector made us realize a specific need to incorporate innovative solutions, especially at the power distribution level. So the Electron Vibe program was developed to focus on utilities deploying innovative solutions from startups that could accelerate the pathway to a modern, resilient distribution grid. I think you'll notice this statement repeatedly, a modern, resilient grid. So since 2020, Electron Vibe has worked with 22 utilities and 63 startups, leading to 20 pilots offered. Now that we're building on that experience, having worked with a lot of these organizations, we want to continue to work on an AI for power innovation platform. The reason is simple. Even when a tool looks promising, it's hard for utilities to move from interest to real use because of data gaps, legacy systems, safety requirements, and procurement challenges. Right? So this platform will actually compose of 3 parts. One, the Electron Vibe program, which is our open innovation platform to ensure that pilots keep on getting deployed. Second, a knowledge hub so that utilities and other partners and key players in the space can share what has really worked and maybe what has also not worked to ensure that the ecosystem continues to be developed. Three, the solutions platform, a place where utilities can find ready tools right now and over time find a safe way to share anonymized aggregated data so that startups can build on solutions that fit utilities needs, right? This is what leads us to this panel actually. What opportunities present itself with regards to AI that will help us on the pathway to a modern, resilient grid. So with that, I would like to invite the panelists up on stage. Abhishek Ranjan, who will be joining shortly. Siddharth Singh from IEA. Sujit Nair, who will be joining shortly. Namrata Mukherjee from the International Solar Alliance. And I'll welcome Dr. Mahesh Patankar as well to join. And I'll hand over the mic to Nalin Agarwal, founding partner of Climate Collective Foundation.
Okay, good. Hi, everyone. So unfortunately, Mr. Tandon from IFC fell ill. He came here, but he decided to not attend because he has a pretty hectic week coming up. Great. So without too much ado, and Sujit and Mr. Ranjan will join us. I think they are in a panel that's running late. But we have already so much experience and knowledge here that I don't want to spend too much time not leveraging that. What we are here is to, of course, discover some new things about what AI can do in the power sector. AI is obviously kind of flavor of the day, but in the power sector, it's already been very active. All of us here have been part of the digitization of the power sector in very different ways. I'll ask each of you to kind of just spend a minute to introduce yourselves and your work, especially around the digitalization and AI of the power sector before I move into specific questions. So, Mahesh, I think you've already spoken about MPN systems. Siddharth, if I can request you.
Thank you, Nalin. Is this on?
I think you have just move this to the right.
Okay. Thank you, Nalin. So it's a pleasure to be here, and this is my first time walking in today for the AI summit, and I'm glad it went smoothly after the entry.
After you got in.
So I'm, of course, I'm Siddharth Singh. I work at the International Energy Agency. I lead the Energy and AI work program at the agency along with a colleague. And we have a big team. We have a team of around 50 people drawn from across the agency who deal with all aspects of the system. So this goes well beyond electricity.
Yep.
But of course, electricity, as you rightly said, is integral and core to the work we do.
Right.
So I work broadly in the team of the chief energy economist of the IEA. So I'm an economist by training. So my lens usually is economics as opposed to core engineering. But of course, AI being a technology, it's important to understand the various facets of it, which include technology, which include the technical aspects, but also legislation, regulation, commercialization, and so on.
Got it. Thank you. Namrata, if I can request you.
Hi, thank you so much, Nalin and Climate Collective team for having me here. I'm Namrata Mukherjee. I'm a strategic planning specialist at the International Solar Alliance. I joined the alliance only last year in June, and before that was working with the USAID South Asia Regional Energy Partnership Program, where we partnered with the Climate Collective in the Electron Vibe program. So great work by the team there. At the International Solar Alliance, what we are doing on the digitalization space, at least, I don't know if it is AI so much, but I would like to comment that we have something called a multi-donor trust fund, where we have donors like GAP, Sequoia Capital, and others, pooling in their funds. The objective is very clear, that the solar deployment story is incomplete without the grids being able to, sort of offtake the complex power which comes in the form of solar and other variable renewable energy sources. So through the multi-donor trust fund, we are trying to do, scalable pilots in Jaipur distribution, utility where we're looking at, developing a digital utility twin of the existing utility, and then looking at how we bring in efficiency from a loss reduction standpoint. So that's the current piece of work that we are doing with, International Solar Alliance in partnership with different funding partners. So, yeah.
Thank you, Namrata, and thank you. Namrata mentioned our work together as well in the Maldives. That was quite a pioneering program. Thanks for support there. All right, we'll jump into the discussion now. The way we're going to structure this is in three parts. One is to understand what AI is really doing for the grid today, right? And this is not what's happening in theory, but really what's happening in real life. Second is how are pilots getting to become large-scale deployments in India and across the global south. So we have international perspective here, of course. And then how do we ensure that the grid becomes truly digitalized and AI powered? So that covers data, compute, trust, and flexibility, right? So that maybe I'll start with you. So from global evidence and the kind of work that you do, which AI applications in power are delivering the strongest system level benefits today? And from that, what do you see the key opportunities for India?
Sure, thank you. So maybe I can start by taking a step back
Yeah.
and just contextualizing and understanding why is it that we are talking about this in the first place.
Sure.
What is it about the energy system, about the electricity system, and about AI that make all of this work,
Sure.
right? We have been noticing, at the agency we collect data. We collect all sorts of data, and the data goes back for several decades. And we are seeing a very strong trend of increasing complexity of the energy sector at large, but specifically the electricity systems, right? So why is it becoming more complex? One is that in general, the electrification is rising. So when I say electrification, it means the end use of energy is more and more electricity compared to other fuels.
Right.
In other words, that there are more types of demand and more types of loads that previously never existed that are now increasingly a part of the load. So one is that there's greater electrification. The second is that there is greater, of course this is not news to anyone, but there's greater variable renewable electricity going into the system. So that was never the case in the past. In the past, the variability maybe came in the form of hydropower, but that was also seasonal in nature. Most of the other sources of electricity were stable. That's no longer the case. Now, with solar and wind, the share of variable renewables has gone from as low as 2 or 3%, just over a decade ago. This is a global level, right?
Sure.
And it's on track to hit 30% by the end of this decade. This is a massive jump of variable electricity in the system. There's, of course, in addition to that, there's increasing batteries to manage that the variability, and there are new types of markets. Back in the day, everything was contracted for years at end. Now it's like there are derivatives of things, and it's a financialization of the sectors happen. So first trend is electrification. The second is more recent, which is that there is an affordability issue that is becoming more and more central to policymakers and regulators around the world. Gone are the days when electricity was heavily subsidized around the world. That still exists in many parts, maybe even in India to some extent, but that's less and less the case at a global level. So affordability is an issue. Especially with all the conflict and all of that happening, it's a priority for governments to ensure that electricity is cheap.
Right.
And of course, the third major trend is that now we have long-term goals that never existed in the past. That we have, 2070 or a 2050 or a 2030 net zero target. Be it at a company level or a country level, or and so on, and that those long-term targets have short-term implications. So these three trends, I think, are the driver to why human intervention is not enough. You need something bigger than that. You need something that is more automated, and this is where it comes in. And again, I don't want to take too much time, but one final point on because and I want to address the question that you actually asked, which is that because the inherent nature of electricity and electrified systems makes AI applications the most appropriate kind of technology layer that can manage that complexity. And just naming one or two things that are especially critical for India. One is improved forecasting of variable electricity
Sure.
generation. And when I say it's not just about, okay, the weather models are becoming more accurate, fine. But that's not enough. For solar and wind, you need minute by minute, hour by hour understanding of, cloud cover in the specific location where that panel is situated.
Sure.
Which is different from just having more accuracy, around the world. So that's just one example. So that, and then the managing the a system that has batteries and on solar generation and so on. Those are the types of solutions that will be more relevant for India moving forward.
Very nice. I think so it's a very nice framework. So complex loads, variable generation, and then the imperative of affordability. I think this is really some of the driving factors. And for everyone, this is the right framing. Variable renewables versus you'll often hear intermittent renewables. In fact, variability is a far better way of describing what we see on the grid. Great, thank you, Siddharth. Namrata, if I can come to you, and this is of course your broad experience. This is it's your broad experience at RTI, now at ISA. What are the real world applications that you're seeing going from pilots, and obviously the duet, you can talk about duet as well, going from pilots to deployment, and what has kind of pleasantly surprised you in that?
Okay, thanks for that question, Nalin. Look, I think from what's working well, let's start from there. And I think I echo what Siddharth was saying. The renewable energy phenomena now is more than a decade old, right? I mean, we started with the solar mission, initial phases, then we saw a lot of wind coming on board because of the policy reforms around accelerated depreciation, generation-based incentive and others.
Right.
So the ingress of renewable energy in our grid is not a very recent story. It's been there for close to a decade. And if we start looking at how the story has spanned over time, right, we are actually talking about a very large capacity now in our grid, more than 50% of renewable energy capacity, including hydro if we take. How did that all come together, right? There, I would think one of the key things which has been happening over the last 5-6 years very well is the uptake of the forecasting in variable renewable energy sources, and that's one of the key drivers for that is again. Generation is a delicensed activity, right? It's all private sector driven. You know that. For renewable energy, you don't. It's not a regulated business, which means the more accurate I am in my forecasting, the more upside I have from a commercial gains perspective. So if you look at the private sector so far in the wind and solar sector, they have picked up very strongly on the forecasting, accurate forecasting of renewables. And one key policy enabler over there has been our deviation settlement mechanism and the 15-minute interval, basis participation of renewables in the markets. So that has all come together to somewhere now link that story as to why greater accuracy of renewables is even more critical, because we'll be moving towards more tighter grids, right? 5 minutes, a minute, frequency linked grids. So I think that is something which has started off well for us in India and is only moving towards getting more strengthened. But that also means that that has to connect to the larger story of us building the India energy stack, having more open source data available so that more innovation can come in that forecasting. So that's the phase 2 of innovation if I look at from a forecasting standpoint. The other good thing that I would think that's happening, at least in the Indian grid, is really the base layer of having data together. So if you look at the whole RDSS scheme and the fact of having 250 million smart meter rollout program announced by the government of India, right? That's very ambitious. To be honest, that is really the backbone of anything that is digitalized and AI ultimately, right? So for me, I think that is again a very core layer that we are moving towards. A lot of the smart meter installations are really starting to give the, data that we would like to see from households and business level. So I think that is again a very good move in the right direction. It is now about how do you connect those again to the larger piece about making that data talk to each other, interact with each other, connecting it to the distributed renewable energy sources, be it rooftop, EV and others. So that I would think is the next phase around where we are already starting to make some moves, but that's where the real focus needs to go.
Very nice. I like that framework. Mahesh, I want to bring you in as well. Whether in DR, maybe DR is a nice one to focus on from you, specific applications you've seen, and even the ones you've seen scale.
Right. So a demand response is a very interesting articulation of the transition that we are seeing. Firstly, the entire grid has moved from generation following load to load following generation.
Yep.
And that's where the entire variability and the opportunities to optimize the grid itself comes into the picture. And demand response is a very interesting democratization of decision making in the energy space. If a particular consumer base, let's assume say all the air conditioner users in the state of Delhi, if they are ready to participate in some kind of a demand response initiative, it's very important for us to acknowledge that they are actually not only consumers, but they are also prosumers of one sort. So I think demand response to me, it's not only about giving a trigger whenever the grid requires that trigger to ramp down, but more importantly, the entire articulation, Nalin, in my opinion, is now changing and needs to change from demand response to demand flexibility.
Right.
Wherein if we have more seasonal variation, or I would say diurnal variations in generation coming up and experience in the grid, it's also important for not us to ramp down, but also ramp up selectively. And I think that goes back to the what was mentioned by Siddharth in terms of increased electrification, and that's where some of the end uses, including for example foundry industry, which conventionally use biomass, is now moving towards electric arc furnaces, and that's where again demand response comes into the picture. So so the status currently is demand response. There are several programs. I'm sure Abhishek ji, when he comes here, will talk about specific examples from BRPL. But I think the entire narrative is now changing towards demand flexibility. I'll just mention one very interesting solutioning that we came up with, which is being currently piloted by World Bank in the state of Uttarakhand, wherein there is a lot of water pumping load that exists in that state because it's a hilly state. So there is something close to 40% of the entire consumption of that state comes from water pumping. It's a big surprise, isn't it? We would imagine there's abundance of water. But all of that groundwater which gets pumped into the Jal Jeevan scheme, which is the water for all, and has some kind of a storage. So what is currently being leveraged is basically a demand flexibility, wherein one can actually bring up the water from underground water tables to the overhead water tanks, and that has inherent storage capacity. So that's basically something which is being planned, and we will actually be exploring the AI applications also there, because at this state level we are looking at something close to 1 gigawatt load, which is available for ramping up and ramping down. At least I would say 20% of that. So I'll just pause here. That's probably the new way to sort of think at a larger scale.
Very nice. In fact, this I would like to bring Siddharth in, because you've done some very interesting research on data centers, and perhaps how they can actually be. We hear a lot of perhaps apprehension around what will happen with demand, but in reality they can be very friendly loads for a grid operator, because they can be firm and flexible. Increasingly we're seeing, in fact we spoke with NVIDIA and Google at COP, and they were mentioning how they've become increasingly able to shift critical and non-critical loads, right? So just a few insights from the research that you did on data centers, and how a little bit of flexibility can improve grid resilience and avoid added capacity as well.
Yeah, for sure. So first let's talk about the global picture of how much electricity is consumed by data centers, and then we can talk about how they consume it.
Sure.
So firstly, at a global level, our estimate was that for last year, about 1.5% of electricity generation goes into data centers. This is expected to rise to about 3% by 2030.
Right.
So it's a doubling taking place. Sure. But what's increasing rapidly is actually the AI portion of it. So data centers do all types of loads. They do not only AI, they also do traditional loads, like if you're watching a Netflix movie, for example. Currently, that AI load is a very small fraction of it. I would say probably less than 20%, like well less than 20% of the total load of data centers today is AI. This grows fivefold. So the portion that is actually AI is growing fivefold. Everything else doubles, but that grows fivefold.
Sure.
That shows that where the growth is really coming from. And AI has a different profile compared to non-AI loads. So
Right,
there's a
right.
greater flexibility potential, especially when big tech companies are able to use data centers that are located in different places and shift loads according to the signals that are given. But the big challenge there is that currently there is not enough regulatory, there's not enough information being passed down as to when and how that should happen.
Okay.
So there needs to be, a layer between data centers and the electrical system that actually enables that kind of, trade or
shifting.
flexibility
I
or
see.
shaving off the demand. In fact, some solutions have come in that space. There
I
are
see.
a few companies, a few startups, including one that NVIDIA works with, since you mentioned them,
Right.
that is working on exactly this problem. So
Right,
they're
right.
able to shift as much as 20% of, or shave 20% of the peak demand when needed without compromising on the actual
Performance.
computation
Yeah.
capability of the data center. And the other issue is that, there have been some questions on what impact will this have on electricity prices and so on. There are different takes to it. One
Sure.
is, of course, that data centers require infrastructure. They require electrical, upgrades, maybe in, a new capacity and so on, and that can have an implication on costs. But at the same time, as you rightly mentioned, they also have higher utilization rates.
Right.
So because they have higher utilization rates, they can, the costs on the system are more absorbed. So they're high utilization rate than the rest of the grid, put together.
Right.
In other words, you're able to distribute the costs a little better. So with appropriate regulation, you can ensure that data centers are more flexible.
Yeah.
But then they're also playing a conducive part in the grid and not actually imposing costs.
No imposing costs. Got it. Very nice. Namrata, anything here, especially given your view of the world basically as ISA, right? And especially data centers being something that can drive real economic demand in many emerging markets. So
Yeah, no, I totally echo what Siddharth was talking about. They are actually, data centers will become the critical demand flexible load for us, supporting the grid as we move forward, right?
Right.
And that's exactly when you start looking at the larger picture of consumer centric grids, right, where every industry, every consumer is able to contribute,
Right.
at the right time. I
Sure.
think data centers will play a very, very critical role in the times to come. So
Yeah,
I'll
yeah.
just sort of
Yeah.
stop.
And of course, you may know ISA works in how many countries?
26.
126 countries, right? So many of them emerging markets.
Yes.
Many of them are seeing data centers as something that's positive for the economies, not just a load on the grid, right?
Correct.
Yeah, please, Siddharth.
I can actually come in on this. This triggered a thought, as you were speaking. Data center companies and big tech companies especially have been pursuing renewable electricity for data centers.
Right.
But there are some very interesting angles to this, right? So, one question that people largely have is, why can't we power data centers entirely by renewables, right? Now, you'll be surprised to know, or maybe you won't be surprised to know, but some of the biggest data center operators in the world, so the top 10 biggest, for example, already claim that on paper, 100% of the electricity in any given year is being met by renewables. In other words, they have, as companies, purchased, paper, they've made paper contracts with generators of solar and wind and so on, which is taking place in a third location. So it could be somewhere very far away. Now, the big challenge is this may happen at a yearly level, but it's not happening on an actual basis because that electricity may be generated at a different time of the day, but the consumption load is different. It is flat and through the year. So how do you match that?
Right.
So for this matching, this hourly matching is the new trend that we are beginning to see. So some companies have taken a lead on it. It's not a global practice just yet, but what they're trying to do is ensuring that on an hour-to-hour basis, 100% of the electricity is met by renewables. And many tech companies have that target for 2030 and 35 and so on.
I see.
So they have met already the 100% yearly target, but they're now moving towards a 100% hourly target.
Yeah.
And that is when, but
Optimization,
having said that, currently most data centers are grid connected, so they do consume whatever the grid provides, which includes generation from other sources.
Yeah. Got it. Okay, very interesting. So we may move to the second section. I was hoping two other panelists would be here, but clearly it's running over. Namrata, I'm going to start with you, and specifically on the policy side. So to get from pilots to large-scale deployments, right, or platforms, what policy tools do you see or have you seen matter most across various countries? You can choose India, that would be fine. So are we talking about regulatory sandboxes, concessional finance, pool procurement, public data platforms, or any others?
Yeah, thanks for that, Nalin. It's interesting because what we're talking about is a transformation which is happening so fast right now. I mean, I've been here in this sector for 22 years now, but these last, couple of years have just sort of changed the whole dynamics of the pace at which things are changing, right?
Right.
Which means that if you look at our discussion here today about digitalization, about AI, when we come back next year, it would have taken a different form and shape altogether. Which means it has an even more sort of criticality to bring the regulations, policies, regulatory policy makers, up to speed with all the changes which are happening.
Yeah, of course.
Because to be very honest, distribution on the consumer side is regulated. That part of the business is regulated, which means the regulator plays a very critical role in defining certain standards, rules, and that's fair also, right? A lot of the policy making also that we do is actually governs what is going to happen ultimately at the consumer level, right? So what I see is that there are 5 or 6 layers to this, and they are not sequential. They have to go in parallel, right? If you're looking at scaling up the digitization story. One is definitely looking at the data and AI governance for renewable energy, which is essentially meaning that we have to now increasingly start making rules for the sector, which allows our distributed renewable energy sources, distribution system operators. We don't have something called DSOs, but we have more like the transmission system operators and the distribution utilities. So that these entities can start talking to each other in the form of data, but with the right privacy security standards that we build. And also the need for us to move more towards open AI tools, which will literally then add to the story of the India energy stack that we're trying to build in the form of the digital public infrastructure, right? So that is one key thing which is the governance framework and rules which has to get created. The second thing is a renewable energy forecasting, compliance framework. Because like I told you, a lot of the generation is private sector driven, so it makes sense for them to do forecasting, right? As a business case. But I think it's a need for regulators to start specifying this. That, if you don't have this forecasting, then your tariffs will get impacted and so on and so forth. So for me, it's very important that there is now an explicit mandate for a regulatory requirement of forecasting for variable renewable energy.
And just to understand, you talk about the signals that a regulator can send would be like the UI charges, right?
Yes, the DSM charges, which we now call the deviation settlement mechanism, right? Also, the second thing around this is updating the grid codes, because we have built grid codes over years. And with the way in which the grid is changing, there's a need for really constantly updating the grid codes, which is then talking with these kind of disruptions which are taking place. I think that's another key aspect which we have to be mindful about. The third thing on the regulatory side, I would think, is a very important aspect about digitalization of utilities and grids, which means that how do you incentivize digital twins, advanced analytics, as Sujit, please come. How do you basically bring advanced analytics that utilities are doing as a part of the regulated grid enhancing investments? Because one has to understand, when a utility goes to a regulator for its annual revenue requirement and tariff approvals, if the regulator is not approving a digital twin related application or advanced analytics, then where will a utility look at these advanced mechanisms? So I think from a regulatory standpoint, that's another key aspect. Then we have consumer centric distributed renewable energy sources, which will now increasingly start coming on the grid. So how do you develop flexible market mechanisms so that these, start talking to each other, which would mean that, what we talked about. We spoke about the demand, the data centers, right? How do these contribute now to your peak shaving, congestion relief, and voltage support mechanisms? So moving towards those kind of advanced market mechanisms in parallel to these regulatory reforms, right? And then 2 other things which are very, very important is, firstly, planning, because if you have to incentivize utilities to plan for digital and AI options when they are doing their resource and network planning requirements to the regulator, right? And somewhere the regulator needs to nudge and tell them that where are those plans,
You're right. Yeah.
So that, and then we could also look at something called a performance-based incentive for utilities who are adopting digital solutions which are leading to improvements, say, in a RE curtailment reduction. Or forecasting accuracy or outage reduction, right? So something around those lines. It's thinking out of the box. I don't know if that's possible, but this is a way of incentivizing. And finally, I would say regulatory sandboxes play a great role in promoting innovation by the regulator. You'll see DERC has announced the regulations which are now talking about P2P trading for electricity using blockchain. UP has already done that, the UPERC. So things like this, I think, are very important, just so that you test and see whether what you're applying is possible to scale at a much larger level.
Nice.
So I'll just stop there.
No, great.
Oh, sorry, and then one small last thing is, I think the capacity building of regulators is extremely important, because while we have a CRC in the center, but we all know at the state level, I mean, if you go and talk to regulators about digital and AI, there's a long shot. So there has to be capacity building, which is a constant. Happens with that.
No, great. I think you brought up so many points. But yeah, I mean, the planning and the performance-based incentives, they seem to have, we've seen them working in other sectors for sure. Great. I'd like to welcome Sujit as well. Thanks, Sujit. What we request is just 30 seconds so that people know specifically what it is you're doing in relation to digitalization of the grid. And of course, that includes a lot of what you're doing at IES.
Yeah, no, thank you so much. Firstly, I must apologize. Looks like I'm not the last one to walk in. I see Abhishek joining me, so I'll probably, get him thrown under the bus in some sense. But so sorry, Abhishek. But yeah, no, really honored to be here. And I was just listening to some of the conversations. So my work seems to ask questions in those areas, but I ask questions more as a technologist. I see myself more as a infrastructure plumber, a digital plumber of sorts, with the work we have done in DPI, and most of my work with DPI, with backend as such, particularly. So I think the work I do is essentially ask, what does it take when things change pretty dramatically? And AI energy are very interesting, because on one side, AI is taking off. Definitely the models are getting better, and of course there is a realistic cost decline that's happening in usage of that. That's one part of it, of course. And I was saying that in the other panel, it's still a lot of supply side hysteria. We need to see the demand side value of it, and also demand side pricing of risk of AI. That's one of the challenges. But energy is peculiar, because about 2 years ago, somebody reached out and said, "Aren't you not thinking about energy?" I said, "No, probably as a trained electronics engineer, I know a little bit, but I can understand Kirchhoff's law, but not more than that." But the larger point about the massive decentralization that's happening, and the fact that increasingly more and more useful energy assets will be outside of the control of the grid, geometrically scaling up, and we people are going to be part of the grid, because we are the ones with solar rooftop generating energy, so we are the grid in some sense as a society at large. Probably it calls for an opportunity to have a little bit of a systems level thinking, without of course upsetting the grid systems. We are not literally trying to do an open heart surgery of how the grid works, but see how do we manage and bring them together. So how do we create open rails that makes this coordination happen, and little learnings from what we have done with all the DPI work in the past seems to be finding relevance here, and that's the space I'm operating in right now.
Very nice. I mean, this is all path-breaking work, not just in India, but globally. I think DPI has brought us a model that is very unique. Is the only alternative to big tech, I think, anywhere. So thanks, Sujit, for being here. Mr. Ranjan, I mean, for many of you, he may not need an introduction. He's probably the leading energy innovation person in India, especially in grids. I definitely consider him. Mr. Ranjan, if I can just request you to take 30 seconds just to talk about your view of grid digitization and digitalization. And I'll come to a specific question, especially because we have just 10 minutes actually. So where have you seen in Delhi's grid, or even otherwise, but since Delhi is very close to you, where AI has created most operational value?
No, of course, so apologies for 30 minutes delay, but then we're talking about exactly the same thing in the last session. Grids have evolved. What Sujit is saying, democratization has happened. Even if we are not aware, it is already happening. A grid is no longer a monolith or a unidirectional thing. It's already a bidirectional, multi-direction thing already happening. So without our knowledge, certainly the changes in the last mile, maybe the production systems, maybe the distribution transformer infrastructure, those things are taking shape. Technology is seeping in. Unknowingly, knowingly it is seeping in. It's not like on one fine day we are going to move there, we are already moving there.
Sure.
What I always say is we are already in some kind of DSO. We are moving towards that. A DER interconnection giver and a DER kind of operator. Right now it is a must run.
Right.
But then as soon as smart grids, smart inverters and the digital twin that we are talking about comes in, we also have now to run that symphony, orchestrate that symphony. That's what it is going to be when you manage all the DERs together.
Right.
Now, one specific point where it has make a lot of difference is 9 years ago in 2017 we started with AI powered machine learning, not AI, machine learning powered models for demand forecasting. That was spot day ahead, and that is an intraday, that is 2 hour ahead. And then it scaled up to forecasting the spot market prices, which is real-time prices and day-ahead market prices. And it makes up to 70 to 80% of the cost of a utility in India, for example. So it made a lot of improvement in the last 9 years. We have been able to save and quantify a lot of power purchase cost, optimize it.
Nice.
Especially if you can see about 20-25% is short term and about 10 to 15% is about on the spot market share in our annual energy purchase that we do. That is hands down. Second, now we are deriving a lot of mileage is from, because the scenario has changed. The people are saying even a flicker is an issue. The government is saying give me a fixed Delhi plan in the next 3 years. So SAIDI and SAIFI, so close to Singapore, if maybe few minutes. It can't be done without investing a lot in technology, and that too last mile technology.
Right.
So we started with pilots again in 2018, 2019, pre-COVID. That was on AI-based platform for predictive and prescriptive asset health monitoring and maintenance. Right. Now it is inbuilt. So we are putting in all those 23 kV, 11 kV feeders on the block.
Right.
Baselining and then using drones or satellite imagery to capture, and then a trigger based MTTF, mean time to failure, and the complete workflow is getting operationalized. So that is again yielding numbers on the Excel sheet. These are the two important things which we are already seeing the value. There are multiple other things which is in the customer space yet to be quantified. Like for example, before you apply for a new connection, you can actually check it online, like Eon does. Eon does allow you. We want to have a customized version of the same here. Until now, it was there in our internal, so we hadn't made it public. So now with the smart meters on the DTs, we have real live view. So you can get to know in a few minutes as to whether your this connection of this much quantum at this location is possible or not. So this is going to be revolution, because people say that you are a monopoly and therefore we are suffering. Okay, so this is going to be other way around, saying that you decide your own place where you want to in the current shape.
Very nice. I mean, that is, for anyone who lives in Delhi, that will be a big help, I guess, right? Okay, Shrijit, I'm going to come back to you. We're all curious about IES, of course. You did mention what it's about in a very, in a very fundamentally broken down way, which is great, right? I want to understand from you is what would success in India's tax style look like for the power sector if you were to include AI? Take a 5-year view,
Yeah, I think one of the things we were debating on IES, and EIS, by the way, still a work in progress.
Right.
We're discovering a lot more serendipitously, and that's a good thing about how you design things at population scale, because you're not curating. Sometimes it emerges from diverse set of use cases we are looking at. But if I were to take a 5-year view and ask this question, of course, grid resilience and flexibility being at the core and center, reliability being at the core of the center, is there an opportunity for us to solve for energy agency? Put people at the center of their energy lives, people and businesses, and give them that agency. And how do you solve for that? Most of the time, I think the the idea that energy is something that is an obligatory burden for a DISCOM to offer and fulfill puts a lot of pressure on the DISCOMs or the utility, the grid in general. Now, the equation is flipped with people having more and more energy. So is it possible for them to be a participant?
Sure.
Not just a beneficiary?
Sure.
And is there therefore a way of coordination that makes them participant and derive benefits, but overall makes it a more self-organizing, self-reliant system? And if that is, that could be one of the visions of the energy stack, and I'm not a sole speaker, opinion maker on that part. There are others, but I think that could be one way to look at it. And what it means is that the marginal coordination cost on getting energy accessible, affordable to billion people should come down to zero. If India is in the solar belt, if we have the kind of assets, maybe that's one of the visions to talk about. And through that, and as we speak, probably there is a Prime Minister looking at one of the early implementations of India Energy Stack, the peer-to-peer interstate trading, thanks to the work Abhishek and all have been done literally in 1 month's time, is to talk about how does it create new livelihoods. You know, telecom revolution created STD booths as a way of livelihoods, and banking did business correspondence. I wouldn't be surprised if youth and homemakers are actually having another, livelihood. I mean, maybe there's a point, maybe somebody in the village will start thinking, should I buy a cow for livelihood or probably get non-self-use energy, solar rooftop and battery to generate some income, and making that possibility. And making that possibility and making people part of that story would be one of the big things about IES. And IES is not by itself a solution. It's very, very important we understand this. It's just the coordination layer. The solutions will have to be designed, brought up. But we think that if more and more such solutions have to come, it is absolutely necessary to have that coordination fabric. Otherwise, we will have, as I was saying in the other panel, in digital, the tendency is that we literally build a road for every car. That's how digital has been. We didn't do that for the energy. We did not build one grid for toasters, another grid for washing machine. We built one grid for all. But in digital, we tend to make that mistake. And that is why the coordination cost becomes so high. With this digital coordination fabric, which is essentially nothing but a bunch of standards and specifications, we should be able to achieve that. Sorry, it was not supposed to be a short answer, but
it's
that's
perfect.
Probably what we are looking
your
at.
Analogy of the grid as potentially a complex adaptive system is very nice for the future. And I mean, there's so much potential of it being an economic driver for individuals. So that's great. I know, I think we have a hard stop. I hope we don't, because we have so much to go through. But I'm going to come back to Namrata once. I'll move to the last sections. Just talk about, given ISA's role and your own experience, South-South learning, how can this be leveraged to leapfrog traditional grid planning and dispatch models, right? And in the context of AI, please.
Okay, thanks, Nalin. I'll keep it brief. Look, I think for ISA, South-South is a little overrated. But I think most important is the fact that we have members across the Sun Belt, across the globe. And with the type of disruption, it was interesting to listen to the Joint Secretary MNRE saying that in the last 18 months, 15 gigawatts of decentralized solar, has got added to the grid.
Right.
Which you can imagine in terms of the, impact on the grid that it'll have if you don't have the backbone layer of flexibility that we're talking about, right, at the distribution level. So I think the way the story of the global south is building is very different from the way in which the north has developed its stories, right? All our stories across the African subcontinent, Latin America, or other regions have a very similar historical legacy grid that we've built, right? So I think from that perspective, it's very crucial that these learnings are more south-south, to say so, and it's customized more because so that we don't leave the rest of the global south on their old journey, but bring them up where, countries like India are moving. Just a little bit of an issue I have with the leapfrogging again terminology, because look, I think grids are very different across countries. You can't think, African sub-Saharan countries move towards where we have moved as India. There has to be a basic, building block of data digital layer that get built before we move towards that journey. So I would say keeping that in mind, but there's a lot to offer from a South-South cooperation.
Perfect. So that, in your view, globally, what are the biggest bottlenecks for powering an AI-powered grid? Is it data access, compute, cybersecurity, skills, or regulatory inertia?
So of course, all of the above. But I'll let the data speak for itself.
Yes,
so we
yes,
did a
yes.
survey, and we, with energy companies and so on. The one that kind of popped up more than any other was skills.
Skills.
So just,
Very
I mean, the talent usually gravitates to the tech sector. There's no surprises there. We did another, bit of desk research to find that for the similar role, you get paid 2x of what you would in the energy sector. The going rate, the going wage in the energy sector is half of what it would be in tech for the same role. So that gives you an illustration of how difficult it is to attract the right talent. And I see the clock ticking, otherwise I would have added
I think
a
the
few
best minds of our generation have gone to sell ads, unfortunately. Sujit, if I can bring you in. Governance principles essential for utilities to trust shared digital platforms. Just a few words on that.
Yeah, it goes back to the point that we may be probably the biggest, most powerful AI agentic outage management for all you can. But if it's not working with the ecosystem and it's working in silo, it isn't going to take off. I mean, if you want to, I keep saying this, it's very, very important that one of the lessons we have learned from India's transformation story has been to rethink how we think about scale. I mean, one is to think about scaling what works, because that's what all engineers love doing, including myself. But it's a completely another thing to think about what works at scale. And the example about the contexts are very different. I mean, there are 84 discoms at different stages of evolution, different styles of doing what they're doing, different motivations at some point, different demographics they deal with. For example, what we're seeing in Delhi versus what we're seeing in a rural district of Jaipur could be very different. So it is therefore important to think about how we make them all agree on a common set of building blocks as a principle. And if we give them, probably that's all that it takes. Just give these building blocks for them to contextualize it to create what is the solution for in there. But having those common building blocks across all is the part that is what is necessary. And that's where these principles will become important. The fundamental principles of interoperability, and India Stack is just doing that. India Stack is saying there are these building blocks. It's fascinating to see out of 55 use cases that we went through, mostly on the DISCOM side, the number of building blocks to solve for all of them are probably not more than 5.
Wow, nice.
But each of them works at population scale.
Wow.
So it also reduces the whole burden on DISCOMs to saying, oh, one, I have this electrification burden of the new load. Then we have this whole renewables. On top of that, you're going to make me write another 15 RFPs on digitizations. I just finished getting my billing system done. But that's not the idea. That's not how we should think about it. So that's where some of these very, very clear design principles make a big difference. And that's what India Energy Stack intends to do.
Very nice. I mean, I know some of the work you're talking about is encapsulated in societal platforms, I guess. So it's a good one for everyone to read about later.
I think societal platform is a body of knowledge that has come out of all the work of design thinking we have done. In India, I think India has probably its own design thinking, which we have managed to come together and call it as societal platform. I think it's more societal thinking because platform is so ancient now. We're more talking protocols, but societal thinking and societal platform is a body of knowledge which sort of embodies these principles and says probably this is how you should think about scale. I would recommend everybody to give it a look.
Very nice, thank you, Mr. Ranjan. I guess if we are on a time, I'll give you the last word. So how should utilities, governments think about AI data centers and units? We did have a comment from Siddharth, a positive comment, as risks or system balancing assets.
So it depends where you are. So in India, we are just starting, for example. Even in US, for example, we are just starting. So if properly planned, it is an asset. And this is going to be a amplifier in terms of how do you balance the grid. And if not, then you're creating another burden on the grid. So I'll be just as brief as possible. So recently, there was an Hitachi event where we discussed the same topic. Where we said that if your siting and sizing of the data centers is very, very important. And so that you're not burdening the existing infrastructure. While also ensuring that it is green. So the data centers can also flex. It's bi-directional, both ways. So even the base load demand will be somewhat fixed. But then there can peaks and spikes when you fire those lot of text heavy or voice heavy or some visual queries, chat GPT kind of when it spikes like this. So those things can be taken care of by on-site and dedicated nuclear stations or battery storage or a mix of both. So yes, it is an asset. You can plan. If you plan it properly, it is an asset.
It's an asset. Well, thank you. There's many more questions, and this is an extremely interesting conversation, but unfortunately, by the powers that be, I think we have to stop now. Thank you all for being here. It's been lovely for me. I hope it's been lovely for you as well.